In this video, we are going to go through some examples about the sampling distribution of sample mean. Example 1. Given a normal distribution with mu equals 50 and sigma equals 5, if you select a sample of n equals 100, this means sample size is 100. What type of variable would we work with? Because we are working with the mean, so the variable we are working with will be a quantitative variable. The sampling distribution, or say the distribution of all possible sample means, is normally distributed. We know it is normally distributed because of the central limit theory. Since we were told that the data started off normally distributed, the sampling distribution is normal regardless of the number of samples poured. Even if we had not been told that the data start off normally distributed, the sampling distribution would still be normal because the number of samples is larger than 30. Pay attention here. We have a sample size equals 100, which is way larger than 30. So if we are given a normal distribution with mu equals 50 and sigma equals 5, if you select a sample of n equals 100, what is the probability that x is less than 48.5? So we know that the population mean is 50, population standard deviation is 5, sample size is 100. And the question expressed in a math language is the probability of x less than 48.5. Again, we draw a normal curve in a scratch paper. And how likely is it to get a value less than 48.5? We want to transfer the x value to a z-score, right? So working with a population distribution with mean equals 50 and the average distance observation from the mean equals 5 standard deviation. Again, we calculate the z-score in this formula, and the z-score is negative 0.3. And we can look at the normal table to have this probability here. This means the shaded area equals to this number. Now, given the same normal distribution with same population mean and population standard deviation, so what if I ask you what is the probability that x bar is less than 48.5? So all the parameters here are the same, and we're looking for the probability x bar less than 48.5. In other words, how likely it is to get a sample mean less than 48.5. So we are working with a sampling distribution with mean equals to mu x bar, which also equals to the population mean 50. And the average distance observations from the mean equals the standard deviation, sigma x bar. It also equals to the sigma, which is the population standard deviation divided by the square root of sample size. So the standard error of the sampling distribution of sample mean is 0.5. So in order to use normal table, we need to calculate the z-score. And for the sampling distribution of sample mean, we calculate the z-score in this way, which is negative 3. Then you can just look up a normal table to find the shaded area. Let's compare last two questions side by side. Notice the difference between last two questions are we're asking either x is less than 48.5 or x bar is less than 48.5. So the part C asks the population distribution with x-axis of the different values the data can take. The keywords here is data. However, in part D, which is the last question, the sampling distribution with x-axis of the different values the sample mean can take. Pay attention, the keyword here is sample means. This is the keyword. This is a keyword, and this is the key difference. Next, the area distance from the mean equals 5. However, in part D, the area distance from the mean equals 0.5. This sentence stands for the standard deviation, the population standard deviation equals 5. This sentence here stands for the population for, the standard deviation over x bar, which is simple mean, equals to 0.5. So in part C, when you are talking about the value of x equal 48.5, it falls 0.5 standard deviation below the mean. So this sentence indicates that the z-value or z-score for part C will be negative 0.3. However, in part D, the z-score will be negative 3. The different z-scores indicates different probabilities. Given a normal distribution with mu equals 50 and sigma equals 5, if you select a sample of size 100, there is a 35% chance that x is above what value? So key informations here are mu equals 50, sigma equals 5, and n equals 100. Looking for the probability of x larger than x. So the given area is 0.35. It implies that the transparent area is 0.65. Then you can look at the normal table to find the z-score here. The last step will be convert the z-score to the x value. So there is a 35% chance that the random variable x is above 51.95. Now I have changed the question to, there is a 35% chance that x bar, or say the simple mean, is above what value? Key informations are still the same, and we know that the sampling distribution is normal. We are looking for the x bar larger than some value, and the value the area to look up is 0.65. We can use normal table to find the z-score here. The last step will be convert the z-score to sample mean x bar. We know that the mean of sampling distribution equals to the population mean, which is mu equal 50. Pay attention that the standard deviation of a sampling distribution will be calculated in this way. The population's standard deviation divided by the square root of sample size. This equals to 5 divided by square root of 100, and also equals to 5 divided by 10. So that's why we have 0.5 here. This is example 7.16 from your textbook. You can pause this video and read the question. Question 1. Identify the random variable x whose population distribution is described here. So the random variable x should be number of years of education for self-employed individuals in the United States. Next question. Find the mean and standard deviation of the sampling distribution of X bar for a random sample of size 100. Interpret the results. So again, the sampling distribution of sample mean will have mean equals to the mean of population distribution, and the standard deviation of sampling distribution of sample mean should be calculated in this way. This means the average of all sample means for all samples possible in the population is 13.6, which also equals the population mean. This also tells us the peak or the middle of the normal curve falls at 13.6. We know that the sampling distribution of sample mean is normal, or I say approximately normal, because the central limit theory tells us when the sample size is larger than 30, in 30, the sampling distribution of sample mean is approximately normal distributed. Last, the typical distance from the mean for all sample means for all samples possible in the population is 0.3, which is same number here. Here is another example from a textbook. You can pause this video and read the question. Here are what we have known for this problem. Since the sample size is larger than 30, so we know because of the central limit theory, the distribution of sampling distribution is normally distributed, even though the population was right skewed. And the population mean is mu equals 8.2, which is the same number here, and the standard deviation should be 3. If the 100 customers on a particular day have the characteristics of a random sample from the customer base, find the mean and the standard deviation of the sampling distribution of the restaurant's sample mean expense per customer. So we know that the sample size is 100, and the mean of a sampling distribution of a sample mean is same as the population mean, which is 8.2, and the standard deviation of a sampling distribution of a sample mean should be calculated in this way. Next question. Find the probability that the restaurant makes a profit a day, with the sample mean expense being less than 8.95. So when you are told to find the probability that you know the distribution is normal distributed, so we are looking for the area under the curve, then you want to calculate the z-score. And using the same formula here, we have the z-score equals 2.5. So we know the value of z-score now, and we can find the area to the left using normal table. So from the normal table, we have the area under the curve will be 0.9938. In other words, the probability that the sample mean less than 8.95 equals to this number. And the question asked is the sample mean expense being less than 8.95. So that's why this equation answers the question here.